Hello, my dear students. Today we are going to revise chapter 1, which is transition elements. So we are going to discuss different types of questions and their model answers. So let us start. The first type of questions today is write the names and symbols of the compounds indicated by letters from A to K in the following diagram. As shown on the diagram here, we have letters from A to K. We have to follow the arrows in order to predict these compounds. As shown on the screen, we started with iron. So when heating iron with oxygen or water vapor, compound A is formed. If you think about it, my dear student, will find it will be magnetic iron oxide that has molecular formula Fe3O4. Then to get compound B, we have to reduce magnetic iron oxide or heating iron to carbonate or heating iron to oxalate. If you write this equation, my dear student, you will find that the compound B will be iron 2 oxide. Then, if you are going to oxidize iron 2 oxide, you will get the compound C. So, if you write the chemical equation, it will be iron 3 oxide. Also, iron 3 oxide is formed by oxidation of magnetic iron oxide and also is produced from heating iron 3 hydroxide or iron 2 sulfate. All of these reactions give iron 3 oxide. Then, when reacting iron 3 oxide with sulfuric acid, it gives compound D. So, if you write the chemical equation or reaction between iron 3 oxide and hot concentrated sulfuric acid, it will produce iron 3 sulfate. And then on reaction of iron 3 sulfate with ammonium hydroxide, we will get compound E. If you write the chemical equation illustrating this reaction, you will find that compound E will be iron 3 hydroxide. So, my dear student, to get compound F, we have to react iron 2 oxide with dilute sulfuric acid. So, if you write the chemical equation indicating the reaction between iron 2 oxide and dilute sulfuric acid, it gives iron 2 sulfate. Then, on reacting iron 2 sulfate with sodium hydroxide, you will get compound G. Here, if you write the chemical equation illustrating this reaction, you will find that compound G will be iron 2 hydroxide. Then we are going to predict what is compound H at the top of the screen. When iron reacts with dilute hydrochloric acid, it gives compound H. If you write the chemical equation indicating this reaction, you will find that iron 2 chloride is formed. When reacting iron 2 chloride with sodium hydroxide, it gives iron 2 hydroxide. This compound has green color. Then, on reacting iron with chlorine, we will get compound G. So, if you write the chemical equation indicating this reaction, you will find that compound J is iron 3 chloride. That iron 3 chloride on reacts with sodium hydroxide, it gives compound K, which is iron 3 hydroxide that has reddish brown color. My dear student, you can use these two last types of reaction that iron 2 chloride or iron 2 salts when reacts with sodium hydroxide gives iron 2 hydroxide that has green color, or iron 3 chloride with sodium hydroxide, it gives reddish brown precipitate of iron 3 hydroxide. Next type of question is choose the correct answer. When iron reacts with dilute sulfuric acid, iron 2 sulfate is formed, not iron 3 sulfate. As what? Is it iron 2 ion is more stable, or the evolved hydrogen gas is reducing agent, or the dilute sulfuric acid is an oxidizing agent, or iron 3 ion is not stable? If you think about it, my dear student, you will find the answer. It will be the evolved hydrogen gas is a reducing agent. Next point, on heating iron 3 oxide by carbon monoxide gas at temperature ranges from 230 degrees Celsius till 300 degrees Celsius, it is reduced to what? Is it iron 2 oxide, or iron, or magnetic iron oxide, or iron 2 carbonate? If you think about it, my dear student, and you write the chemical equation representing this reaction, you will find the answer is magnetic iron oxide. Next point, when magnetic iron oxide reacts with concentrated sulfuric acid, what are produced? Is it iron 2 sulfate and water, iron 3 sulfate and water, or iron 2 sulfate and iron 3 sulfate and hydrogen, or iron 2 sulfate and iron 3 sulfate and water? My dear student, if you write the chemical equation representing this reaction, you will find the answer. It will be iron 2 sulfate and iron 3 sulfate and water. My dear student, remember that this equation proves that magnetic iron oxide is a mixture of two oxides. Next point, we can get iron 3 chloride by what? Reacting with dilute hydrochloric acid with iron, or passing chlorine gas over red hot iron, or passing hydrogen gas in iron 2 chloride solution, or passing hydrogen sulfide in iron 2 chloride solution. If you think about it, my dear student, you will find the answer is passing chlorine gas over red hot iron. Next point, on passing steam over red hot iron, it gives what and hydrogen? Is it iron 3 hydroxide, or iron 3 oxide, or iron 2 oxide, or magnetic iron oxide? If you think about it, my dear student, you will find it will be magnetic iron oxide. Next point, on heating iron 2 oxalate, in the absence of air, what is produced? Is it magnetic iron oxide, iron 3 oxide, iron 2 oxide? If you write the chemical equation representing this reaction, you will find it will be iron 2 oxide. Next point, when iron reacts with dilute sulfuric acid, iron 2 sulfate is formed, not iron 3 sulfate. As what? Iron 2 ion is more stable, the evolved hydrogen gas is reducing agent, or dilute sulfuric acid is an oxidizing agent, or iron 3 ion is not stable. If you think about it, my dear student, yes, the answer it will be the evolved hydrogen gas is reducing agent. The next type of question here is give reason for. Iron reacts with chlorine giving iron 3 chloride, not iron 2 chloride, while it reacts with sulfur forming iron 2 sulfide. The reason for that, because chlorine gas is stronger oxidizing agent than sulfur, as it has higher electron affinity. Next point, Iron reacts with dilute acids forming iron 2 salts, not iron 3 salts. If you think about it, my dear student, you will find the answer is the produced hydrogen gas is reducing agent that prevents the formation of iron 3 salts. Next point, iron 2 reacts with concentrated sulfuric acid forming both iron 2 salts and iron 3 salts. Because sulfuric acid is a strong oxidizing agent giving both iron 2 and iron 3 sulfate. As the equation proceeds, 3Fe plus 8H2SO4 concentrated and heating gives iron 2 sulfate and iron 3 sulfate and sulfur dioxide gas and water. Next point, iron does not react with concentrated nitric acid. The reason for that, because the iron forms non-porous layer of iron oxide preventing further reaction with the acid that we call passivity. Next type of question, choose the correct answer. The alloy which is used in the manufacture of MiG fighter jets made of what? Is it scandium with aluminum, vanadium with manganese, scandium and silicon, or zinc and titanium? If you think about it, here's the answer, it will be scandium with aluminum. Next point, the alloy which is used in the manufacture of car spring made of what? Is it vanadium steel, or vanadium and manganese, or scandium and silicon, or zinc and titanium? Yes, if you think about it, the answer it will be vanadium steel. Next point, the alloy which is used in the manufacture of drink cans made of what? Is it aluminum and manganese, vanadium and manganese, scandium and silicon, or zinc and titanium? If you think about it, my dear student, you will find the answer is aluminum and manganese. Next point, the alloy which is used in the manufacture of railway track made of what? Is it iron and manganese, vanadium and manganese, scandium and silicon, or zinc and titanium? If you think about it, my dear student, it will be iron and manganese. Next point, the alloy which is called bronze made of what? Copper and tin, vanadium and manganese, scandium and silicon, zinc and titanium. If you think about it, my dear student, it will be copper and tin. Next point, element which we use in dental implants and artificial joints. Is it scandium, or titanium, or iron, or zinc? If you think about it, my dear student, it will be titanium. Next point, element which is used in hydrogenation of oil to produce fat. Is it scandium, or nickel, or iron, or zinc? If you think about it, my dear student, yes, it will be nickel. Next point, in the first transition series, the ion is more stable when the 3D sublevel is half filled, or completely filled, or empty, or all the previous. Yes, if you think about it, it will be all the previous. Next point, the maximum value of oxidation state in elements of first transition series occurs in vanadium, or chromium, or iron, or manganese. Yes, if you think about it, it will be manganese. Next point, all the following compounds are iron ores except what? Is it magnetite, or limonite, or dolomite, or hematite? Yes, if you think about it, it will be dolomite. Next point, iron is found in free states in what? Is it siderite, or meteorites, or Earth's crust rocks, or alumina? Yes, if you think about it, it will be meteorites. Next point, On heating iron 3 oxide in the presence of mixture of carbon monoxide and hydrogen gases, it is reduced to what? Iron 2 oxide, or magnetic iron oxide, or iron, or mixture of iron 2 and iron 3 oxide. If you think about it, my dear student, it will be iron. And you know that this is the equation of reduction in matrix furnace. Next point. On heating iron 3 oxide with carbon monoxide gas, it is reduced to what? Is it iron 2 oxide, or magnetic iron oxide, or iron, or mixture of iron 2 and iron 3 oxide? If you think about it, my dear student, yes, it will be iron. And remember, this is the equation of reduction in blast furnace. In the same period of transition elements, as the atomic number is increased, its ionization energy decreases, or its diameter increases, or it is difficult to be oxidized, or its density decreases. If you think about it, my dear student, you will find the answer. It will be, it is difficult to be oxidized. Next point. Zinc 2 ion is characterized by its diamagnetic property due to what? The presence of 3d paired electrons, or 3d sublevel is filled by 8 electrons, or 3d sublevel is empty, or the presence of unpaired electrons in 4s sublevel. If you think about it, my dear student, you will find the answer is the presence of 3d paired electrons. Next point. Iron 2 ion is characterized by its paramagnetic property due to what? The presence of 3d unpaired electrons, or 3d sublevel is filled by 10 electrons, or 3d sublevel is empty, or the presence of unpaired electrons in 4s. If you think about it, my dear student, yes, the answer it will be the presence of 3d unpaired electrons. The next type of question is write the scientific term. Substances which are repelled with the external magnetic field because all their electrons are paired. Yes, if you think about it, my dear student, you will find the answer. It will be diamagnetic substances. Next point. A substance that is attracted to an external magnetic field due to the presence of unpaired electrons. If you think about it, my dear student, it will be paramagnetic substance. Next point. The absorbed color from visible spectrum by transition element. If you think about it, my dear student, it will be supplementary color. Next point. The reflected color from the visible spectrum by transition element. If you think about it, my dear student, yes, it will be complementary color. Next point. Elements that have partially filled D or F sublevel in their free state or ionic state. If you think about it, my dear student, it will be transition elements. Next point. Elements in which D sublevel is successfully filled. If you think about it, my dear student, it will be main transition elements. Next point. Elements in which F sublevel is successfully filled. If you think about it, my dear student, yes, it will be inner transition elements. Next point. Elements in which 3d sublevel is successfully filled. If you think about it, my dear student, yes, it will be first transition series. Next point. Element in which 4d sublevel is successfully filled. If you think about it, yes, the answer it will be second transition series. Next point. Elements in which 5d sublevel is successfully filled. If you think about it, my dear student, it will be third transition series. Next point, elements in which 6d sublevel is successfully filled. If you think about it, yes, it will be fourth transition series. Another type of question here. Give reasons for. The abnormal electronic configuration of chromium and copper. Because, my dear students, chromium has electronic configuration argon 18 for S1 3d5, which means that the 3d here is half-filled sublevel, which have lower energy and extra stability, while in copper has electronic configuration argon 18 for S1 3d10. That means that the 3d sublevel is completely filled with electrons, which is more stable and less energy. Next point, transition metals show several oxidation states. The reason for that, because their valence electrons in both 4s and 3d sublevels. That means they are near to each other in energy and so lose the electrons from them successfully. Next point, all first transition series have oxidation number positive 2, except scandium has oxidation number positive 3 only. The reason for that, because the scandium electronic configuration argon 18 for S2 3d1, when it loses 2 electrons from the 4s sublevel and 1 electron from the 3d sublevel, it gets an empty d sublevel that is more stable. Next point, the maximum oxidation of first transition series states increases from the scandium positive 3 till manganese positive 7. This is due to losing electrons from 4s then 3d sublevel according to the oxidation state. Next point, the oxidation states of first transition series decreases from manganese positive 7 to zinc positive 2. The reason for that is the increase in the ionization energy as the increase in the positive nuclear charge. Next point, the oxidation of iron positive 2 to iron positive 3 is easy, while that of manganese positive 2 to manganese positive 3 is difficult. The reason for that is due to iron has configuration argon 18 for S2 3d6, so iron positive 2 has argon 18 3d6 that when oxidized to iron positive 3 has a configuration argon 18 3d5. That means it is more stable since it has half-filled d sublevel, while in manganese has configuration argon 18 for S2 3d5 that when oxidized to manganese positive 2 has configuration argon 18 3d5 that when oxidized to manganese positive 3 has configuration argon 18 3d4. Next point, zinc and cadmium and mercury are not transition elements. The reason for that is have completely filled d sublevel in all their free states and ionic states, which is the configuration argon 18 for S2 3d10 for their atoms and their ionic states argon 18 3d10 and for S0. Next point, coin edge metals of group 1b, copper, silver and gold are transition elements because in the free states copper that has configuration argon 18 for S1 3d10 and in the ionic state positive 2 copper positive 2 will be electronic configuration argon 18 3d9 or positive 3, the 3d sublevel will be partially filled with d9 or d8. Give reasons for. iron ore is heated strongly in the air during extraction of iron? Because of drying the ore to get rid of the humidity and converting the ore into iron 3 oxide to increase the percentage of iron, such that the iron 2 carbonate, when it is heated, gives carbon dioxide and iron 2 oxide. Then iron 2 oxide, when it is oxidized in air, giving iron 3 oxide. So we have increased the percentage of iron from 48.5% till 69.6%. Or if we use limonite ore that has percentage of iron 40%, that has molecular formula 2Fe2O3.3H2O, by heating it gives 2Fe2O3 and water is produced. Here the increased percentage of iron from 40% till 69.6%. Next point, the atomic radius of the first transition series is nearly constant from chromium to copper. This is due to two factors which are opposite to each other. The increasing of the positive nuclear charge that increases the attraction of the electrons, or the increases of the number of electrons in the 3D sublevel that increases the repulsion between the electrons. The first transition series have high melting and boiling point. The reason for that is the strong interatomic bonding, which is metallic bond, that involves the electrons of both 4s and 3d sublevels in their electron cloud. Next point, the density of first transition series increases with increasing atomic number. The reason for that is their atomic mass increases with increasing atomic number, while their atomic radius is nearly constant, as density equal high mass over constant volume. Next point, the first transition series have variable chemical reactivity. The reason for that, because copper has low reactivity while iron has medium reactivity, as it rusts when exposed to air, while scandium has high reactivity. Next point, the first transition series are attracted to an external magnetic field. This is due to what? Is due to the presence of unpaired electrons in the 3d orbital, such that the magnetic field, which is resulted from their spin motion, is attracted with the external magnetic field. Next point, the magnetic moment of first transition series determine the electronic configuration of their ions. The reason for that, because the measurement of their magnetic moment indicates the number of unpaired electrons in their d sublevel. Next point, iron 3 compounds have higher magnetic properties than iron 2 compounds. The reason for that is the electronic configuration of iron positive 2 argon 18 3d6, so have 4 unpaired electrons in the d sublevel, which have lower magnetic moment than iron positive 3 that has configuration argon 18 3d5. Next point, the elements of the first transition series act as catalyst, because the electrons in the 4s and 3d orbitals form weak bonds with the reactant molecules, so increasing their concentration at the catalyst surface that weaken the bonds in the reactant molecules and decreasing their activation energy, and so increases the rate of the reaction. My dear students, we have finished our program today. I hope you understood these different types of questions and their model answer. Be careful, my dear student, you have to write the chemical equation in balanced equation and write the physical state of reactants and the products and the condition of reactions. So Till we meet again, my best wishes for you.